intermittently. All right, so we're going to enter some data now. Before in Desmos, you could add some data in a table, right? But we don't have that option. So in GeoGebra, we have these tools will change depending on what we click in. Now over here, we've got some more options for settings and things like that. And we also have these three. Can you see on my screen? Yeah. Just about. It's not quite there, but the menu bar. Okay. All right. So we've got lots of them. Now, I am actually going to click on these three dots here. All right. And we are going to open a spreadsheet. Okay. All right, so where that is, it's not in the three dots, three lines, sorry. It's in the menu here, three dots there, and I don't have it because it's already open. Okay. So I'm going to. Right. Do you know what? I am just going to read. This is the trouble with it. So do that, three dots, spreadsheet, I've got both though. Sometimes things get closed, you see, and it's like, oh, how do I reopen that? Now we're going to enter some data. Now the data I've got is age. Okay, so we can put age in there, and age is actually in years. And then we've got percentage of population who wear glasses. Just so you can see. It doesn't really matter. All right. And I'm going to put some data in. So I'm going to start typing it. I'm going to pause the video and then you can just. Was it recording when I typed? Okay, so this is the data we're going to be using. Now, you might be able to see that at the moment, all right, 8 and 10 look. So if I show 8 and 10, there's no point there. It's not appeared. It doesn't just appear like it does on Desmos. We've got to do something else first, okay? All right, so are we all there with the data yet, or do I need to give you a bit more time? Yeah. By the way, what I've done in the past is made this process part of an assessment, so give you some data and say, do this, take a screenshot, send it to me. So if you want to make notes or whatever, we've got the video, so, but, using the technology is part of what you have to be able to do in this topic. Okay, so to make the points appear, what I'm going to do is I'm going to highlight the data. All right, so click and hold and highlight. And I'm going to go over here, and you'll notice the tools are different now. All right, I'm going to go to this, where the numbers are, the 1 and the 2. I'm going to click on it, okay, and I'm going to create a list of points. All right, so if I click that, you'll notice I've got something new and I've got this. Right, I could mess around, but I'm just going X to Y, that's what I want. age percentage is dependent on, so that's the way it's going. So this is my X, this is my Y. Click OK. All right. Now, just to check, I should then have 8 and 10 visible. There we go. So I've got 1. Yeah, just press enter, OK, whatever.
It's not working.
So I'm going to go to settings, right? That's settings wheel. Over here it appears, that's the trouble with this, it's a bit more complex because it all starts appearing. I'm going to change my X minimum to the minimum value, or just below it, I'm going to say 5. X maximum needs to be up to 70, so I'm going to 75. The Y goes from 10 up to 92, so I'm going to put 5 up to 100 maybe. All right, and there you go. That's what I've chosen to do, and mine looks nice and spread out. So if you just use your scrolling wheel, you might find it doesn't look so nice. So now I've got this sorted, I can close that off, right, get that out of the way. Now I got it how I kind of want it. I can now drag it around and I can zoom out a little bit. The zoom in doesn't matter, but if you now look at my number there, right, it's still about the same scale, but my axis numbers have changed, right, because I've zoomed in with the wheel. So, but by setting that scale, the pattern looks quite nice. It's not a vertical line up the screen, so that's an important aspect. So yeah, I mean, if you've got more space above, your line will look flatter, right? So if I just show you that, if I change my Y maximum to 250, look what mine looks like. It just looks flatter. Yeah. It's not changed the data in any way. It's just how it looks. Which criterion is that we have to consider? C, yeah, your communication. So as long as you are communicating well. Now look, if I decide, oh no, I want mine to look like Mr. Potts, I'm just going to zoom in and out. It doesn't do anything to that, does it? All right. So what has happened is you can see your scaling 1 to 3 is different. So if I want to change that, I'm going to change the Y max back to 100 and it was 18, and now I've taken up the space again. So that's part of my communication. So change your Y value to a smaller number and it will go up a little bit more. But it doesn't change the data, okay? It doesn't change the data. Now, before we do anything else, form, strength, direction, tell me. Positive, linear, strong, I'd go with strong, yeah. Moderate rather than medium. Medium is not really a word we use. I would go with strong in this case. Yeah. Right, we're going to put a line of best fit in. Now, a line of best fit, okay, if you look at the sheet I gave you, obviously I can't show it on the video, or no, I don't know, maybe I can. No, right, so one thing, 0 is not a point on a scatter plot unless it's a point on the scatter plot in the data, right? We'd never pick an arbitrary point that's got nothing to do with the data. We can't rely on a single point in the data to represent everything. Doesn't make sense, right? This point here could be way off, right? So we have to actually add a point that represents the data. 1 point. So it represents the data but isn't in the data. So this is all important for you. So I don't know whether you want to make a note or whatever. We'll do it again. We'll probably make some notes afterwards. But the point that we need to add a point, and it's called the mean point. So basically we take the mean. What's another name for the mean? That's another version of what the mean is. An average, yeah? We take an average. The mean is one of the averages. Do you remember how to do it?
Yeah. No. I've never done add all the numbers and then divide by as many numbers.
add up all the numbers and divide by all the how many numbers you've got. So in this, I'm going to add another point. I would need for age, I want the mean age. So I'm going to add up all these numbers and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, because it's the age number.
Yeah. Go for it. So when you are adding up the numbers and dividing by the number of numbers, one important check for the mean is it must not be lower than the lowest and it must not be higher than the highest. It must be somewhere in the middle, otherwise you've done something wrong. So if you get a mean of 78, 78 doesn't represent that data at all. So now, well done those that got their calculator out straight away, added it all up, love it. There is a little shortcut as you'd expect on the computer. If we click this symbol, we can actually do the mean. That symbol means add up, so add up divided by n. So if I click that, sometimes it becomes a 0. I'm going to redo it. So I'm going to actually do the other one first. Click on that. Select, actually, what was it saying? So I'm going to select the numbers, click mean, and I get that. I'm going to select the numbers, click mean. Sometimes it gets 0, so I'm going to, for some reason, it just wants to do it again, right?
Where did you get that?
So if I'm clicked into my spreadsheet, I get the tools for the spreadsheet. If I click in the graph, I get the tools for the graph. If I click in the tools for the other one, well, that doesn't change. So spreadsheet, highlight, click on that, the mean. So I agree, 36.44. Like I said, sometimes it does, and you just have to do it again. Sometimes I go on to the next one, do it, and go back to it, and it fixes it. I don't know why. It is just a bit strange. And we're going to highlight that, and we're going to just be aware of where it's going to appear. It's going to be somewhere around the middle. I'll tell you why. And then I'm going to go to click list of points again. Okay. Which point have I added? J. Now here's a nice little touch. I'm going to click on J. All right. And you can see up here, when I click on a point, I can change stuff about it. And I'm going to change this to red. Right, just so that I know it's, okay. You know, I could even change it to a different shape if I like. But what's the last point that you created? So you should have a J, because we should have A, B, C, D, E, F, G, H, I. And then your new point will be somewhere in the middle. What's it called? Did you do the list of points thing again? Highlight it. The mean point. Remember, to put it on the graph, we have to go highlight, 1, 2, list of points, click OK. But this time we're only doing it for the new point, so it should appear. Okay? As long as you identify it and then change what it looks like so we know it's not in the data. Doesn't matter. So we've got our mean point. You've changed what it looks like. You've changed its color. All right, we're all there. Right, make sure you're clicked into this and you've got these options. What you're going to do is you're going to click on the one that is the point tool, and you're going to click on point. And I'm just going to click up here, make a new point. Make sure it's out the way of the data at the moment. All right. Again, I can probably change this to a different color, different shape, just so I know it's not part of the data. All right, you all done it? So the next bit is we need a line of best fit. So we're going to use this point as our construction point. That's all it is. And this point is the point the line has to go through. Are we all at this stage? Yeah? Right. So you're now going to click on the line tool. And you are going to create a line, not a segment, a line. because it goes on forever between the 2 points. Now, be very careful with this, that just like the points, you don't start clicking everywhere. So we're going to click line. Now I'm just going to move over. I'm going to click my point up there. And you think, oh, nothing's happening. But trust that it has. And then oh, look, I'm not clicking. I'm going to go and I'm going to tell it. I'm going to click on J. Once I've done that, I'm going to immediately go to my arrow and click on the arrow. Because if I don't, all right, I'll get lines appearing everywhere. And then I have to click on the arrow, click on the line, and delete. All right. So for instance, if I click line, click here, and then I go, oh, okay, oh, no, what? All right. So I can start getting in a mess. So if I do that, just go over to here, and then I can just start unticking what I've just done. And I just want this. All right. Is that a line of best fit at the moment? No. So this is what's nice. I'm just going to zoom out a little bit, give myself some space. I'm going to make sure I'm on the arrow, and I'm going to click on the K. I'm going to move it. And I'm going to line up my line of best fit where I think it should be. There you go. That's where I think my line of best fit should be. Now I can take a screenshot and put it into Word, and there's my line of best fit. There is one extra thing that we can use this for. All right. Now we are going to have to do two things. Well, one thing that we're going to have to do is we have to know the equation of the line. Do you remember doing equations of lines earlier in the year? Please say yes. Please say yes, Mr. Potts. I remember doing gradient and intercepts and standard form and blah. Yeah, yeah. There you go. We all loved that. We were all so good at it. So I could realistically, once I've got this line done, I could work out the gradient and intercept, right? And I could work out the equation. So that will be a skill we'll have to do. We'll have to practice it because we can't rely on computers. But what is quite nice, if you go over to this bit here, you'll notice that there is a line been produced and it has an equation. What form is it in? It's not mx plus. But what's it called? This one's in standard form. It's got ax plus by equals something, right? We can change that. If you right click on it, you can change it to mx plus b or ax plus b form, right? If you click that, it will tell you the equation of that line, which we could write down. And we can use that for the predictions. Now, you will probably have a different line to me, a different equation, yeah? Why is that?
Your line is a bit.
Yeah, like, look, if I, what's good about technology, if I change it, the equation changes, right? So ours will be slightly different depending on where we put our line.
Like if you put it in the middle where the zero is, it's like, it'll go. It'll go 0 point something.
Yeah. Now, that doesn't mean that's the right one. I mean, it depends where you think the line of best fit should be. And there is actually a mathematical way of getting it spot on without having to guess like this, but not for this year, right? It's called linear regression. The computer can do it for you. But that's what's important. You now have a set of data. I want two things. So what does a line of best fit have to go through now? A mean point. We should have a mean. That's the only point it has to go through, but it does have to go through. So if I ask you to do a line of best fit through some data and you forget your mean point, your line of best fit for me is not a valid one. Yeah. Right, that word valid. You know, you could have done things correctly, but it doesn't go through the mean point. All right, and having the mean point gives the line something to, it helps me even line up my ruler if I'm doing it on paper. And then we've got the equation, which the computer is very easy. It gives us it. It's very nice. But if we have to do it by hand, we're going to do gradient and intercept form, which we'll have to practice both. All right. How do you feel about that? Okay. If I now said to you, so orange box, it says we can use the line of best fit to make predictions of other results. So for instance, if I said to you, all right, predict the percentage of population who wear glasses if they are 37 years old, what do you think your answer will be? And how do we do it? Okay.
Wait, how old are they?
37. So, again, I can't really show this on the computer. I'm drawing on the board. I would go across, if I'm doing it on paper, I'd go across to 37, yeah? It's about, so that's the 37, roughly about here, and I would go up, yeah? It's a brand new pen. What a scam. So I would go up, and I read off, and I go across.
Oh yeah, I remember this now.
What percentage?
30.
Between 40, is it about 50, yeah?
About 50.
About 50% of 35-year-olds would be wearing glasses, right? Another way to do that is I would say, right, if y equals 1.58x minus 6.93, I would then say y equals 1.58 times 35 minus 6.93. Can you tell me what that answer is, please, on your calculator?
35 because of the percentage.
Yes, exactly. So instead of drawing it with lines on the graph, right, which I would normally put on PDF annotator, 48.37. Now, can I get you to work out the same number, so for x 35, but on your lines? So you each have an equation, right? So use your equation to work out what your prediction would be. So I think about 48% of 35-year-olds.
I got 41.7.
You got 41. So you're using your equation that you found down here.
I did something.
So you're all hey?
48.
48.58. Oh my
4.5.
goodness.
So we're all about the same, aren't we? We're all about 48, so our lines are best fit generally. Why is that a reliable prediction, do you think?
No, because if you zoom in,
Really?
the 30, it's not 35, it's like...
Let's not go over the top. Right, your answer, I've just put 35 into my equation. I don't need to zoom in to make the equation any more different. Alright? Is my equation, is my line of best fit a reliable source of prediction? What do you think?
Can you say that again?
That again,
Please.
please. Or do you want me to say something?
Say what you just said again.
What you did not say. Is my prediction, is my line of best fit a reliable source for the prediction?
Yeah.
Why?
Yes.
Because the line you're drawing for the prediction, it meets with the line of best fit.
But that's not what I'm asking. Because I didn't use this line, I used the equation. I've used that line, but I didn't draw it. If I was drawing it by hand, it would be a bit like, that's a bit dodgy, isn't it? Not got very good accuracy, it could be a problem. But still, the reliability of my prediction is based on one thing. What is it?
The line of best fit, because as you move it, the equation changes.
Yeah, but I've decided that's what it's like. That's my line of best fit, that's my equation. Is my equation a reliable prediction tool? There is something we have talked about.
For the mean?
No, not the mean. The mean is set by the data. This case, it is actually quite a reliable one to use. And it's because of one of form directional strength. Which one? Why strength? The relationship is a strong one, which means all the points are quite close to the line, which means using the line and the equation is a relatively reliable thing to do, yeah? Now I'm going to introduce you to something very... Actually, do we have time? What time is...
Yeah,
10 o'clock, we've got time. Okay, so one thing, and we're going to make some notes about this, it's a matter of you not writing it, but you might choose to. If the strength is strong, then our line of best fit is quite useful. If our data is all spread out, mean will still go in the middle of the data, but all the data will be spread out, right? And the line will go through the middle. So my prediction is based on the line, yeah? So if all the points are nowhere really near the line just goes through the middle. How useful is the line?
Not very.
Not very. So the weaker the correlation, the less reliable my prediction is. Now there's one other thing. Can we make a prediction, please? All right. I said 35 years old. So how much of the population need glasses when they're 35? We're predicting about 48%. Okay. Can you predict how many people that are 90? So, can you predict how many of the population at the age of 90?
With your
Around
with yours
65.
Use your own.
or
Around 65. That's what
90 years old.
I look at this one.
Oh my.
Oh wait, no. 133.41.
I'm 133.
You can't go above 100.
There you go. That's the point, right?
126.
Did you're all getting numbers above 100%,
Yeah.
right? So basically, it's saying everyone above the age of 90 needs glasses and more. Is that true?
No.
So is that prediction reliable?
No.
I'm going to introduce you to two words which we will talk about. Coming lessons. What I did here, that's nice and reliable, we're happy with that? This one, and I will need you to remember these words, this is called interpolation. Alright? If I asked you to go to 90 and it's above 100%, when I go what's called outside of the data set that I've got, right? So I've only got data from 8 up to 77, right? If I go beyond that, I do something called, anyone know? Extrapolation. You might have heard that word being used before. If someone has data and they're going to go, oh, from that I can extrapolate that, it basically means that I'm just going to make an assumption. But to extrapolate means I'm going to go beyond the knowledge I already have. So if I'm trying to predict outside of the data, it's called extrapolation. And immediately, as soon as I'm extrapolating, there's a potential that I might be completely wrong. Now, we've seen that, haven't we? Because what if the data, well, this one's linear, right? But what if after the 70s, it just starts going flat? How would I know? I don't have that information. So if I start extrapolating, my reliability goes down. Does that make sense? Now, sometimes you might be able to make a judgment and go, that's perfectly fine. But in this case, I can already see that extrapolation just not going to work, right? 130% for people wearing glasses. This line must stop at 100, right? That point's already out of place. But those two words, interpolation means in it, right? Interpolation, and then extrapolation. Extra meaning going beyond the data that I've got. All right? Make sense? Okay, so let's just summarize. Line of best fit must go through the mean point. Okay? Not average, because it has to be the mean. It's not the median, it's not the mode point, it's the mean point. Okay? When is a line of best fit less reliable to make predictions from? When there's a weaker correlation. If I interpolate, that means I'm doing what, Matthew? And what am I doing from in? What have I just been doing? I've been making, begins with P. Predictions. I've been using my line to predict values. If I'm interpolating, I'm predicting from within the data that I have. So it could be quite reliable. If I start trying to extrapolate, what am I doing? I'm trying to make predictions based on stuff I don't know, but I can, sometimes it's okay, sometimes it's not. That's up to me to interpret. All right? And you need to be able to use your technology. So next time, I guess we'll have a bit of practice with some other questions. All right? Cool. Let's wipe it up. Let's go.
Thank you, Mr. Watts.
We're on the grid, Mr. Clark.
I know. Saw it coming.